Okay, so we're given at a certain time for borrowers with good credit scores. The mean debt in their installment and revolving accounts is $15,015. If we assume that it's normal distributed and the standard deviation is $3,540, it gives us some probabilities. So first off, excuse me, I've taken the liberty of setting the amount of debt for a given account to be X. So just for shorthand, so we need to find the probability for part A that X is greater than 18,000. And we're going to do this by finding a z-score first. So this is going to be X minus the mean over the standard deviation. So that's going to be 18,000 minus 15,015 all over 3,540. And if you calculate this out, you will get that this is 0.84 on a z-score. And this corresponds to a probability that z is less than or equal to 0.84. This corresponds to, looking at our table, 84, 0.7995. However, we're looking for a greater than here. So in reality, so this is equal to probability that our z is greater than or equal to 0.84. So that's going to be 1 minus the probability of less than 0.7995. You get 0.20, oops, 05. All right, part B. It wants us to find the probability that the debt for a borrower with a good credit score is less than 10,000. Okay, once again, we're going to find our z-score using the same formula. It's going to be 100,000, sorry, 10,000 is 15,015 all over 3,540. Plug that into a calculator and you will get that this is a z-score of negative 1.42. My phone is on. I apologize if you heard that. All right, so this is going to be the probability that z is less than or equal to negative 1.42. If we look at our table, we find that that is equal to 0.0778. All right, we need to move to a new page. So I'm just going to rewrite the mean just for reference sake. And our standard deviation is 3540. Yeah, 3540. All right, next, we need to find the probability that the debt for a good borrower is between 12,000 and 18,000. So this is part C, and it needs to be between 12,000 and 18,000. So all right, so let's find two z-scores. I'm going to write them as z lower and z upper. So z lower is going to be the same formula. Divided by that. And when you plug that into a calculator, like I am doing right now, that is negative 0.85. And for this one, it's going to be 18,000. Should get a positive z-score for this because it is above the mean. And this is 0.84. So what we're really asking for is the probability that the z-score is between negative 0.85 and 0.84. And from previous exercises, we know that this is the probability that z is less than 0.84 minus the probability that z is less than or equal to negative 0.85. So if we look at our table, so that first probability is, oh, wait, we found that earlier, didn't we? Yeah, I'm smart. 0.7995. Subtract out. Here it is. 0.1977. And when you do that, you get 0.6018. All right, finally, part D. Sure, another page. And then transcribe all this info once again, because I just want to make sure it's all in front of me. Starting having to refer back and forth. We need to find the probability that the debt is no more than 14,000. So it has to be less than 14,000, or less than or equal to. Not that it really matters. I don't know why I chose to write in the dollar sign, even though I didn't write in the dollar sign for any of the other parts. Oh well. So time to z-score this. Same old. Last first, same as the previous. That did not sound as right as I thought it would, but sure. Anyway, this rounds to a z-score negative 0.29. So we're finding the probability that our z-score is less than negative 0.29. If we look at our table, that equals 0.3859. And there you have it.